Did you know Pluto is considered an outlier in our solar system? Its highly elliptical orbit, even crossing other planets, made Pluto reclassified as a dwarf planet back in 2006. Just like Pluto, outliers in data can obscure general trend and lead to bad decisions in business and science. In today's video, we'll show you how robust statistics and interquartile range detect outliers and keep your analysis accurate. Plus, we'll walk through a real Kaggle example how robust statistics visualization in box plot enhances decision making, along with sharing bonus point at the end regarding effective data visualization. But first, let's begin by understanding why outliers can be problematic.
Outliers are data points that stand out as significantly different from the rest of the data. They can distort analyses and lead to faulty conclusions. For instance, a high salary like $200,000 in a company where most salaries range from $45,000 to $60,000 can skew the average, providing a misleading picture of typical annual salaries. Consequently, it can have negative impacts, not just in business, but in science as well. In science, such as astronomy, Pluto's reclassification as a dwarf planet highlights how an outlier can disrupt public understanding. For 75 years, Pluto had been the ninth planet, but its small size and highly elliptical and tilted orbit made Pluto an anomaly. In 2006, the International Astronomical Union excluded Pluto because it doesn't fulfill the third planet criterion, in which it hasn't cleared its orbit of other debris, although Pluto is in orbit in the Sun and has a spherical shape. This decision created confusion, particularly in educational materials for children and parents, who were struggled to accept the change. In business world, for example, Target, as major retailer store in the US, used predictive analytics to target pregnant customers with ads for baby products in 2012. Although it worked, there were still outliers, such as non-pregnant customers buying pregnancy items like unscented lotion, leading to incorrect targeting marketing. One case involved sending baby product coupons to a teenager, which raised privacy concerns. These outliers damaged Target's reputation, caused misguided marketing, and resulted in a loss of customer trust and credibility.
With these issues in mind, we need a better way to handle outliers. Let's dive into how robust statistics can solve for outliers issue. But before that, if you found this video valuable, please consider subscribing my channel so that you will be informed for my future video in data science and analysis for business settings to improve data literacy skill. Feel free to drop comment below and I'd be happy to answer. Okay, let's continue.
Robust statistics are designed to handle outliers without losing focus, such as being not easily distorted by extreme values. They give a helicopter view of what's typical in a dataset. Two examples of robust statistics are the median and interquartile range, or so-called the IQR. Ever wonder why salary reports in the news often use the median instead of the average? Here's why. The median is a robust measure of central tendency, representing the middle value in a dataset. Unlike the mean, which can be skewed by extreme values, the median remains stable. For instance, if most people annually earn between $60,000 and $80,000, but one person makes $300,000, the mean salary would be pulled up, giving a misleading average. The median, however, accurately reflects the middle of the group, let's say for $75,000, showing a better sense of what's typical. Now, that's the logical number you want to have. Another key robust statistic is the interquartile range, or IQR, which measures the spread of the middle 50% of the data, or the median. To calculate the IQR, we must first find Q1, or the 25th percentile, and Q3, or the 75th percentile, then subtract Q1 from Q3. The 25th percentile, or lower quartile, is the point where 25% of the data falls below, and the 75th percentile, or upper quartile, marks where 75% of the data falls below. The IQR gives you a sense of variability in the data without being thrown off by extreme values, unlike the range, which just looks at the difference between the minimum and maximum values. In IQR, the normal data range lies within 1.5 times the IQR from Q1, or the first quartile, to Q3, or the third quartile. Any data points outside this range can be considered outliers, while those within the range are considered normal. In other words, IQR acts like a lens, helping you focus on the true heart of the data. Therefore, outliers, as defined by the IQR, can be ignored, leading to more reliable data analysis.
In short, robust statistics measurement in median and IQR are perfect for datasets with skewed distributions or asymmetric, as well as extreme values, while traditional statistics work best for symmetric datasets, which is very rare in real business data. Now, let's dive into the house prices dataset from Kaggle to make decision by understanding boxplot in Python.
First, we'll load the data and make sure we have the right Python packages for data visualization using Seaborn and Matplotlib. To clean the data, we'll remove any rows with missing values in the price, number of bedrooms, and year built columns using the drop function. Second, since the number of bedrooms varies widely, from 0 to over 10, we'll categorize them into ranges using the classify bedrooms function. This function will group the number of bedrooms into specific categories as follows. After applying this bedroom function, we'll create a new column to store these bedroom groupings. We'll also make sure the categories are in the correct order, from the lowest to the highest number of bedrooms. Finally, we'll use a boxplot to visualize how house prices differ across these bedroom categories. The boxplot will give us a clear idea of how prices change with the number of bedrooms.
The boxplot illustrates how house prices distribution shifts in the same direction with number of bedroom when there are less than 10 bedrooms. Outliers, shown as points outside the whiskers, can be ignored as the focus is on the values within the whiskers. The median price increases with more bedrooms, and price variation is greatest for homes with less than 10 bedrooms. However, homes with more than 10 bedrooms show less price fluctuation. Now with this information available, you can make decision on which house you should choose just by looking at number of bedroom. As a bonus chapter, to create an effective data visualization in boxplot, we start by formatting the house prices on the y-axis as currency, using commas for thousands and disabling scientific notation. We then ensure the plot is properly labeled, with the title sale price versus bedroom category, the x-axis labeled as bedroom category, and the y-axis as sale price. To enhance clear visualization, we remove outliers by setting the show flyers parameter to false in the boxplot function, which helps avoid displaying extreme values that could distract from the overall trends. Now, the boxplot presents a professional data visualization, enabling the audience to make more informed and reliable decisions when purchasing a house based on the number of bedrooms. You might wonder why not remove outliers using the IQR formula instead. The issue with this approach is that it can sometimes flag normal data as outliers, like in this image, leading to misleading conclusions. By simply hiding the outliers in the plot using showFlyers parameter as explained before, we maintain a more accurate representation of the data's general pattern. As we've seen, effective data visualization in boxplot can really elevate our analysis, helping us making better decisions. But simply relying on this boxplot is not enough. Click here on this video if you want to learn basic data visualization using context and clean design, so the audience can focus on what really matters. Thanks for watching my video.